Hello everyone and welcome in the next video. Today I will go through different types of filaments available and how to choose the right one for your prints. I will walk you through the most common ones like PLA, PETG and TPU, but we will also look at advanced materials like carbon fiber blends, polycarbonate and even high performance filaments like PPS. I will try to cover everything: how they print, what they are good for, what kind of temperatures they need, whether they need drying, and how tough and brittle they are. Let's start with PLA, the most popular filament in the world of 3D printing. PLA is easy to use, affordable, and perfect for beginners. It prints at low temperatures, usually between 190 and 220 degrees Celsius, and doesn't need a heated bed, although printing on a bed set to 50 to 60 degrees helps with adhesion. PLA doesn't absolutely require drying, but it does absorb some moisture over time. So if you want clean prints without stringing, drying it at around 45 degrees for a few hours helps. In terms of strength and durability, PLA is hard but also brittle. It won't bend much before snapping and it doesn't like heat. Anything above 60 degrees can cause warping or softening. It's also not great outdoors because it degrades with UV exposure. But for decorative prints, toys and prototypes, it's still one of the best choices. And you can print it really fast on most modern printers. Then we have Silk PLA. This one is similar to regular PLA, but has additives that give it a shiny glossy finish. The printing temperatures are slightly higher, usually around 210 to 230 degrees, and it benefits from a 60-degree heated bed. The glossy finish makes lines less visible, but it can also reduce mechanical strength a bit. Silk PLA is fantastic for display models, trophies, or anything where you want that eye-catching smooth finish. Drying is definitely recommended here to avoid stringing and blobbing during prints. Next up is PLA-CF. That's PLA reinforced with carbon fibers. This one's all about stiffness and matte finish. It prints somewhere between 200 and 220 degrees with a 60 degrees heated bed. Drying is a must with carbon fiber PLA, around 45 degrees for several hours, or you will see inconsistent layers and weak adhesion. Because of the carbon fiber content, it's a lot stiffer than regular PLA and less brittle, but it's also abrasive. You will definitely want to use a hardened steel or ruby nozzle for this one, since brass will wear out quickly. Now let's switch things up with TPU, the flexible stuff. TPU is rubbery and bendy, making it perfect for phone cases, gaskets, and anything that needs to flex. It prints between 200 and 220 degrees, and the bed can be set anywhere from 30 to 45 degrees, depending on your setup. Drying is really important with TPU, since it absorbs moisture like crazy. A few hours at 50 degrees will do the trick. Printing it slowly, around 20 to 40 mm per second, helps a lot. And if your printer has a direct drive extruder, you will have a much easier time compared to Bowden setup. TPU can withstand up to 100 degrees, is super tough and almost impossible to snap, but it's also not as dimensionally precise as rigid filaments. Moving on to PETG. This one is like the perfect middle ground between PLA and ABS. It's tougher than PLA, more heat resistant, and still pretty easy to print. PETG usually prints at around 230 to 250 degrees, with a heated bed set between 70 and 80 degrees. It does string more than PLA, so good retraction settings and dry filament are the key. Dry it at 50 degrees for a few hours for the best result. PETG can handle around 80 degrees and is UV resistant, what makes it great for outdoor parts, brackets, or even containers. It's a bit flexible, hard to break, and has a glossy surface, but it can be sticky during printing, so a smooth PEI sheet or glue stick helps avoid damaging your build plate. Closely related to PETG is PCTG. It's a tougher, slightly more forgiving version of PETG. It prints in a similar range, around 230 to 250 degrees, with a bed temperature between 70 and 80 degrees. Like PETG, it benefits a lot from drying at 50 degrees. What makes PCTG stand out is that it's more impact resistant and less prone to stringing or layer adhesion issues. If you've had trouble printing PETG cleanly, give PCTG a try. It's especially good for parts that need to survive rough handling. Now let's talk about ABS. This filament was once the industry standard, but it's fallen out of favor due to how tricky it is to print. ABS prints at 240 to 270 degrees and needs a hotbed, ideally between 90 and 100 degrees. It warps easily, so an enclosure is basically mandatory, and it also releases fumes, so good ventilation is important. ABS is tough, impact resistant, and can handle temperatures up to 100 degrees. But it's not UV resistant, and exposure to sunlight can make it brittle over time. It definitely needs to be dried, ideally at 70 degrees for at least 6 hours, or you will see popping and poor layer adhesion. If you want something similar to ABS but better for outdoor use, try ASA. It prints at 240 to 270 degrees with a similar bed temperatures around 90 to 110 degrees. ASA is UV and weather resistant, making it a better choice for parts that will be exposed to the elements. Like ABS, it warps, so again, enclosure and ventilation are key, and drying it at 70 degrees will drastically improve your prints. There are also fiber-reinforced versions of ABS, like ABS-CF and ABS-GF. The CF stands for carbon fiber and GF for glass fiber. Those are great for structural parts because they are very stiff and less prone to warping than plain ABS. You will want to print them around 240 to 270 degrees with the bed at 90 to 110 degrees and dry them at 70 degrees. Just like other fiber-reinforced filaments, they required a hardened nozzle. Then we have ASA mixed with Kevlar. This is a more exotic filament, but incredibly durable. The Kevlar fibers make the filament highly impact resistant and give it excellent wear resistance. Printed at around 250 to 270 degrees on a bed heated to about 100 degrees and dry it at 70 degrees before printing. If you are building anything that needs to take a beating and live outside, like drone parts or automotive components, ASA with Kevlar is a solid choice. Now let's move on to nylon. This filament is known for being extremely tough and slightly flexible. It prints at high temperatures, usually 240 to 270 degrees, with a bed around 90 to 110 degrees. But it's extremely hygroscopic, meaning it absorbs water like a sponge. If it's even slightly wet, it will print terribly. Drying it at 80 degrees for 10 hours or more is absolutely essential. Nylon is very strong, can take a lot of impact, and handles temperatures up to around 120 degrees. It's great for gears, hinges, or any part that needs to flex under pressure. Polycarbonate, or PC, is another high-performance filament. It's incredibly strong and temperature resistant, often up to 140 degrees, but it's also one of the hardest to print. You will need a hot end that can go above 260 degrees, and a bed temperature of 100 to 120 degrees. You also need an enclosure and very dry filament. Dry it at 80 degrees for 10 to 12 hours. PC tends to warp a lot and needs very good bed adhesion, but if you can get it to print well, the results are incredibly strong and clear, especially for mechanical or electronical components. And finally, PPS. This is a high-end industrial filament used in aerospace and automotive applications. It prints at extreme temperatures, 300 to 340 degrees, and needs a bed at around 220 degrees. You absolutely must dry it at 100 degrees for at least 12 hours, or the results will be terrible. PPS can handle over 200 degrees in operating conditions and is chemically resistant, super stiff, and highly durable. But it's not really a material for beginners. So that was a lot to take in. But now you've got a complete overview of the most common and few advanced 3D printing filaments. Each one has its sweet spot, and knowing when and how to use them can really take your prints to the next level. Let me know in the comments which one's your go-to material, or if there is a filament I missed to mention. If this helped you out, give it a like and consider subscribing. More 3D printing tips and reviews are coming soon. Thanks for watching and see you in the next video.